Alright, so in our last video we talked about mean absolute deviation, which is one form of analyzing data, looking at how the data is dispersed according to the mean. So today we're going to talk about two ways that you can look at the data, and probably a little bit more accurate analysis of the data than the mean absolute deviation would be. Before we talked about not using the negative signs with mad, okay? And if you used a negative sign in the mad, you made me mad. So this time you're actually allowed to use the negative sign. So variance and standard deviation are the two things we're talking about today. Alright, so variance is another measure of dispersion. We use this symbol here, and that is read as sigma squared. Alright, sigma squared. So that is how you say that. To calculate the variance of any set of data, we're going to go ahead and take a look at the data we used in the last video. We have to find the mean, of course, because that's what we did when we were talking about the mean absolute deviation. So again, you add all your data together, and you get 448. And you divide that number by the quantity of numbers in your data, so that was 8, and we got an average or mean of 56. So that equals the mean. Now to get the variance, all you have to do, it's very simple, is take the difference between each value in your data set, and subtract the mean from it, and then take that number and square it. So I've gone ahead and taken each value of our data and subtracted 56 from it, and then squared it down here. So 52 minus 56 squared, 48 minus 56 squared, so on and so forth. So take a moment to go ahead and copy that down and understand why I did that. Alright, the variance is the difference between the value in the data set and the mean, and then you take that number and square it. And of course, once you've done all of that, you divide by 8. So I'm going to quickly go ahead and do this. If you need to slow down, you can pause the video. If you need to fast forward through this part, go right ahead. But 52 minus 56 is negative 4 squared, plus 48 minus 56 is negative 8 squared. Alright, plus, 60 minus 56 is 4 squared, plus 55 minus 56 is negative 1 squared, plus 59 minus 56 is 3 squared, plus 54 minus 56 is negative 2 squared, plus 58 minus 56 is 2 squared, plus 62 minus 56 is, 6 squared. And we're going to divide all that by 8. So one more simplification here, actually two more. We're going to do negative 4 squared is 16, plus negative 8 squared is 64, plus 16, plus 1, plus 9, plus 4, plus 4, plus 6. Okay? I'm sorry, 6 times 6, which is 36. Alright, and we're going to divide that number by 8. Okay, if you pick up your calculator and plug those in, or you could do it on a piece of paper, that's fine. You get 150 divided by, not 6, but 8. So we're going to divide by 8. And your answer for variance, or sigma squared, in this case is going to equal 18.75. Now what exactly does that number mean? It doesn't mean much, because all we did when we squared these numbers was make the number positive, because we didn't want to deal with any negative numbers. So by squaring it, you make it positive. But really what it's saying is that each set of our data is a certain number, each value in our data set is a certain number away from the mean. Okay? And that has a purpose. Okay, and really the only purpose is to find variance is to then go ahead and find what we use as standard deviation. So once you've calculated your variance, you move on to standard deviation. And standard deviation simply is the square root of the variance. And we say that that is sigma. All right, and sigma equals the square root of sigma squared. So, oh my goodness, sigma squared. Pardon my handwriting, but it's late in the day and I'm trying to get this done. But so sigma is going to equal sigma squared. All right, so all we have to do is take our 18.75, all right, which is sigma squared in this case, and find the square root of it. So you pick up your calculator, you do your square root of 18.75, and you get 4.33. Now there's more numbers after that, but I always round to the closest hundredth. All right, but the more decimal places you have, the more accurate your standard deviation is going to be. So what does this all mean? All right, what this means is, in my set of data, I have a 56, all right, and there's a standard deviation of 4.33, which means to the left, I can go down from 56 to 51.66, right? Actually 77. Anyway, or I can go here. Let me actually do that on the calculator. 56 minus 4.33, and I get 51.67. Sorry, 51.67. And to the right, I'm going to add 4.33, and I've got 60.33. So what that is saying is that our data is pretty well dispersed between 51.67 and 60.33. So well dispersed, in fact, that 95% of the data falls in that range. Okay? So it's pretty good accurate representation of where your data is exactly according to the mean. Now, you can then go from standard deviation to what we call the z-score. Okay, the z-score is simply the distance, all right, the distance from the how many so it equals how many sigmas or standard deviations a number is from the mean. But lucky for you, we're going to talk about z-scores in the next video. So go ahead, jot down your notes. All right, if you have questions, go ahead and watch the video again. If you have even more questions, you come in and ask them anytime. All right, we'll talk about it in class, but hopefully this didn't confuse you too much. Remember, we're talking that you don't cast dispersions unless you're analyzing data. See you next time.